Now, we're going through this really quickly, right? Tan of tan inverse, okay? Again, without having to put in values, okay? What kinds of things are you going to expect out of this? Well, when we did sine inverse, we just got the line, okay? When we did cos inverse, we got the same line, okay? They were both restricted, right? Because this was restricted and this was restricted, okay? So, what's the restriction on tan inverse of x? What's the domain restriction?
Oh, it's not inclusive.
Right.
And it's minus
It just goes for all real values,
what?
right? So therefore, you know, since this restriction here locked us in here between -1 and 1, right? Seeing as there's no x restriction on tan inverse of x, we ought to expect that it would not have an x restriction for the whole thing, right? And you can go ahead, you can test out some values, sure enough. It's y equals x, but this time, it's just y equals x. Okay, it's equal to x for all real values of x. Okay? Alright, now, last one. Tan inverse of tan. Now, there is a restriction on this one, right? What's the domain restriction on this function, tan x? What do we choose?
It is now not inclusive minus pi on 2.
Yeah, that's right. It's very similar to sine, but not quite. Sorry, sine inverse. Okay, so I'm not going to get those endpoints. So I'm going to get that same kind of shape, like this, but I'm not having those endpoints. Now, what happens? I am actually going to get you to take your calculators back out again and give this a go. Okay, if I'm at pi on 2 here, at minus pi on 2. Okay, so I'm trying to determine what happens over here, right? Before, with cos and with sine, we got this bouncing thing, okay? So let's try a value. Let's try a value like, say, if this is pi on 2, let's try pi. What value do you get when you say tan inverse of tan pi? You'll get 0. So I'm here. Okay. Now that's interesting. At least at the moment, it looks like it could be doing the same thing that sine was doing, right? It looks like it could be doing this. How would you know if it did that or not?
Test another point.
Yeah, let's try another one. What value looks like it would be useful to us here? Well, if we test in between here, right? That's between pi and 2 and pi is 3 pi and 4, right? So what's tan inverse of tan 3 pi and 4? Now you're probably going to get some weird number, right? And that's because everything's in terms of radians, right? So can anyone work out what it's actually equal to? You might want to multiply by something. Does anyone got a value? Is it positive or negative? It's negative, isn't it? Right? It's negative, right? So we're in trouble, at least for this, hypothesis, this proposal. It clearly can't go through here because it's actually down here. Okay. So if I remember right, it should be minus pi on 4. I think. Anyone want to verify that? You can multiply before and you get 3 4. Yeah. Okay. Good. All right. So I'm here. Where do you think this is going? Can we test another value that'll be, that'll give us something useful? What might you test? Maybe 5 pi and 4 on the other side. Okay, what are you going to get? What would you guess?
1/4.
You're getting the positive version of that, right? You're getting pi and 4. Okay, so what does it look like it's doing? It looks like it's doing this.
It's doing the tan thing.
Right? And tan is periodic, right? So you're probably going to expect the same kind of shape to repeat over and over again. So I've got 0 here, that would make this minus pi, there's pi, and it goes on and on and on. It's got all these holes in it. Why does it have so many holes?
Because it has asymptote.
Good. These pi and 2, minus pi and 2, and so on, they correspond to the asymptotes of tan x, right? Again, the domain of this guy, this inside function, if you like, it defines the domain of the whole lot, right? So tan x exists everywhere except for minus pi and 2, pi and 2, 3 pi and 2, and so on. Okay, so that's why we have those holes. And that's what it looks like.